today's notes are all about the trapezoid rule for approximating the area under a curve. So let's start by just remembering from geometry what the formula for the area of a trapezoid is. And the area of a trapezoid is going to be 1/2 one base plus the other base times the height of the trapezoid. So if we think about this, what we're really doing is this part right here is averaging the bases. So if I was looking at this trapezoid, here's my base and a base. And so the part in blue is just finding the average, which is often called the median, which you might remember from geometry class. And then the height is going to be our perpendicular height between the two bases. Okay, so just a nice little reminder of the area of a trapezoid. Today's topic is the trapezoidal rule. So far, we've approximated the area between the function and the x-axis. Remember, sometimes above, sometimes below, moving from left, moving to right, that whole thing. There were 3 types of sums that we've done so far. We have worked with a left-hand sum, we have worked with a right-hand sum, and we have done the midpoint sum. So left hand, remember we partition off and then we use the heights at our left hand to create rectangles. Right hand, we partition off, we use the output at our right hand values to create the heights of the rectangle. And then midpoint, we go to the middle of our partition, sub that into the function, and that gets our height. The name that characterizes the left hand and the right hand, just those two, are Riemann sums, right? Riemann rectangles using the left hand or the right hand height. And remember, sometimes the left hand over approximates, sometimes the left hand under approximates, likewise with the right hand, and that all depends on if your function is increasing or decreasing. We will have over or under approximations, and that's where you want to just sketch out your little graph real quick, right? So if your function is decreasing, your left hand is going to be too big. If your function is decreasing, your right hand is going to be too small. If your function is increasing, your right hand is too big, and your function is increasing, your left hand is too small. The midpoint then, I mentioned in class briefly, midpoint over or under approximates based on concavity, which we're going to look at a little bit more here in just a second. All right, well, there are 2 more ways to effectively approximate. Remember, we're not finding the exact area. We use the fundamental theorem of calculus for that. But to approximate the area when we only have certain data sets, we can use the trapezoid rule, which is what we still need to do today. And then Simpson's rule actually uses little parabolas. Okay, we're not going to do that in our Calc 1 class, but it is kind of cool. So if you want to look it up online, you can do that. Here are pictures of the trapezoidal approximations, though. So a trapezoidal approximation, instead of relying just on the left-hand height and creating a rectangle, or just using the right-hand height and creating a rectangle, the trapezoid rule averages those two, and we create this nice blue trapezoid that becomes a better approximation than either the left or the right. Just like the midpoint was a better approximation, the trapezoidal rule will be a better approximation. Now, your trapezoids will over or underestimate based on the concavity, okay? So, questions I already answered for you. Does a trapezoidal approximation provide a better approximation for finding the area between the curve and the x-axis? Yes, it does. When would a trapezoidal sum over approximate? A trapezoidal sum will over approximate when your graph is concave up. And again, a quick sketch will show you that, right? If your graph is concave up and you create one trapezoid out of that area, well, then you have over approximated. A trapezoidal sum will under approximate when your graph is concave down. And again, just think about a quick graph. If your graph was concave down and you were to use one trapezoid to approximate the area, you're missing a little bit of area, okay? So what this does for us then, trapezoidal sum over approximates when concave up. This is when your midpoint will under approximate. So midpoint, remember we partition off, we find the middle, okay? When the trapezoid under approximates, concave down, the midpoint will be the over approximation. So using the midpoint height, that one's going to over approximate. So increasing and decreasing, deal with left hand and right hand being too big or too small. Concave up, concave down, deal with trapezoid or midpoint being too big or too small. You'll see examples of this, don't worry. All right, there is a formula for trapezoidal approximations, and it looks really intimidating and it's very scary, but the good news is you never have to use this formula. Don't use it, okay? What this formula does is finds a pattern within the trapezoids. We're going to find an even better pattern, all right? Mr. Lakin left some room for you to draw some zoids that are trapped. You are welcome to free the zoids. Okay, so example 1 of 3, calculator active. Use the trapezoidal rule to estimate this integral. Remember, we're estimating, we're approximating for n equals 6. So this is the integral from 1 to 3 of 1 over x dx, right? So I can just slide that dx over. This is 1 dx. So what I've done for us is I have provided the graph. This is the graph of 1 over x from 1 to 3. And I'm supposed to use 6 trapezoids. Well, the way we find the width of each trapezoid, remember we do b minus a over n. N, I said it, but I didn't write it. N, which for us is 6. So we end up with a width of 1/3. All right, well, I need to partition off my x-axis. So I know I'm supposed to start at 1, and then I'm supposed to move a third out. So 1 is the same thing as 3/3. So then I would be at 4/3, then 5/3, then 6/3, then 7/3, then 8/3, then 9/3. So here are my 6 trapezoids that I'm going to work to find the area of. So my first trapezoid is going to have an area of 1/2. My base 1 is f of 1. My base 2 is f of 4/3. And then my height, right, my perpendicular part, is that 1/3 partition. Okay? So again, here's my B1, f of 1. Here's my B2, f of 4/3, times the height, which is my 1/3. I'll get that actual number in just a second. The red one, or the orange one then, I'm going to go between these two. I'm going to have my area of that orange trapezoid will be 1/2 my B1, which now is f of 4/3, plus my B2, which is f of 5/3, times my height, which is again just 1/3. Yellow trapezoid is going to cut across this way, and I'm going to have a green trapezoid, then a blue trapezoid, and finally a purple trapezoid. We've got a nice little rainbow of traps going on here. So what I would like for you to do is take a minute in your calculator, okay? So this is where you can use your calculator, and I want you to evaluate each of the areas of these trapezoids. Okay, so this one, the yellow one, will be f of 5/3 plus f of 2 times 1/3. And then think about what the green, the blue, and the purple are going to be. And then I want you to find the approximated area. So the integral from 1 to 3, 1 over x dx is approximately what? Okay, so pause your video, do some number crunching in your calculator, and see if you can get all 6 trapezoids with the correct answer. We'll compare in just a minute. Pause your video, do some number crunching. Remember, your function f, sorry, I should have said this before, your function f is 1 over x. So when I write things like f of 1, it means do 1 over 1. F of 4/3 would be 1 over 4/3. All right, don't get caught up in the notation. All right, so here's what I came up with. Again, just doing some number crunching. These were my 6 different trapezoids. Well, if I want to approximate the full integral, I'm going to take those 6 areas. So 0.292 is what I came up with for red. 0.225 is what I came up with for orange. 0.183 for yellow. 0.155 for green. 0.134 for blue. 0.118 for purple. And so total, I get 1.107. 1.107. All right, so there's my approximation. Now, if you're sitting there saying, Ms. Schwartz, that seems like a lot of work, you would be correct, okay? So we're going to find an easier way to do this, all right? And what I want you to look at is this column right here. F of 1, F of 4/3, F of 5/3, F of 2, F of 7/3, F of 8/3. Those are all of our left hand heights. Then, looking at our second column here, F of 3, F of 8/3, F of 7/3, F of 2, F of 5/3, F of 4/3, that's all of our right hand values. Then this 1/3 showing up that's going to multiply by each thing, that's our widths. So it looks like I could just take 1/2 times my left hand rule plus my right hand rule. And that's going to be our new shortcut. Okay? So our official shortcut for the trapezoid rule is to find the left hand rule plus the right hand rule, and then divide it by 2, which is the same thing as taking 1/2. Okay? So we have 2 more examples to do, but I want you to put this, the trapezoid rule, it's really, really big. You're going to write left hand plus right hand rule, and then divide by 2. So no longer do you have to do individual trapezoids each time. You can do left hand rectangles plus right hand rectangles and divide by 2. That'll get you your trapezoidal approximation. Okay? So in going back to these examples, I want you to pause this video, try them for yourself, okay? But this time again, use the shortcut. So find a left hand rule, find a right hand rule, add them together and divide by 2. You can unpause when you're ready to check answers for both example 2 and example 3. Pause now. Try for yourself. Draw a picture if you have to. Okay, so there's a lot of calculator work here. I wrote this out in general notation, and then I used my calculator. F of 0 would be 1 plus 0 cubed. F of 1/2 would be 1 plus 1/2 cubed. As a helpful hint, it might be easier instead of doing 1/2 in your calculator to just type 0.5. Instead of 3/2, type 1.5. But for my left hand rule, I got 2.783, and my right hand rule, I got 3.783. So I added them together, divided by 2. This trapezoidal approximation with 4 trapezoids would be 3.283. Example 3, this one had a width of 1/5. So when we talk about our rectangles, it's always going to be 1/5 times the height, plus 1/5 times the height, plus 1/5 times the height. I drew a little x-axis here just so I could see my partitions as I was going. Again, for calculator work, instead of typing in 1/5 over and over and over, just use 0.2, okay? Just a little bit easier to type in. Also, notice that when we talk about our left-hand rule and our right-hand rule share these 2 things. So when you go to type in your right-hand rule after you found your left, don't retype in everything. That's so much work. Use these same 2 values, or I guess in this case, same 4 values, when you're finding your sum. That'll make things a little bit easier for you. So this one, my trapezoid rule, my left hand was 1.109, my right hand was 1.192. Add them up, divide by 2. My trapezoid approximation with 5 trapezoids is 1.150. There's a free response question. Oh, that's our formula again. There's a free response question that I'm going to make a separate video for to make sure we understand this fully. All right, but again, big thing about a trapezoid rule, left hand plus right hand divided by 2. Think about concave up and concave down being over or under depending on your curvature. That's it. Go ahead and watch your next video.